So today we're looking at linear relationships. So anything linear, we're talking about straight lines. So it works two ways. We've either got a straight line, which is linear relationship, or when we're talking about plotting stuff or tables, it means that the increases are the same with every step. So it creates a straight line, and we'll see that later. So consider the following image. Here I've got three pictures. In the first picture I have 3 dots, in the second picture I have 5 dots, and in the third picture I have 7 dots. If I say that the number of dots increases as we move along, which we can see, and we call D the number of dots, and N is the picture number. So in the first picture N is 1, in the second picture N is 2, and so on. We could deduce an equation which tells us how the dots change as N changes. In this case it would look like first to second dot, N goes from 1 to 2, we increase by 2. Second to third, we increase by 2 again. So it's safe to assume that from the third to fourth, we increase by another 2. The equation would look like this. D, which is the number of dots, is equal to 2 times the N, the picture number, plus 1. If we look at this equation and we said N to be 0, where we have no pictures, how many dots would I have? Well, the equation tells me I have 1, and we can check to what we know by plugging in 1 for N, which is our first picture, and we'll have 2 times 1, which is 2, plus 1 gives us 3, and that's exactly what we've got in the picture. So we know that the equation is right. We could put this in a table and see if the dots change or whether they're dependent on the number N. So the table would look something like this. Just as we did with the pictures, I could say that to go from 1 to 2 increases by 2, 2 to 3 increases by 2. So what do you think the missing value would be for the fourth picture? Well, if it increases by 2 every time, it's safe to say it would be 7 plus 2, which gives us 9. So here's our table again. We had N, which was the picture number, and D is the number of dots corresponding to that picture. If we wanted to plot a linear relationship, we can plot the relationship between D and N on a number plane. We place the independent variable N on the horizontal axis, which is our x value, x-axis, and we place the dependent variable D on the vertical axis. So from the table I can see that in my first picture I had 3 dots. In my second picture I had 5 dots. Third picture I had 7 dots. So I can see by this graph I could take my ruler and put it along all these points and they would all lie perfectly on the edge of the ruler. So it makes a straight line. So the fact that I've plotted these points and it gives me a straight line tells me that this is a linear relationship. So just to sum up, the independent variable is always on the horizontal axis and the dependent variable is on the vertical axis. And we're going to talk a little bit about dependent and independent in just a second. So one way to think about it is a little jingle, why be dependent? So Y is always the dependent, so why be dependent? Here's a bunch of examples of things that you could plot on a graph. So you could have age and salary, homework hours and test results, hair color and ethnicity, so on and so forth. For each of these examples, I want you to pause it right now and have a think about which of these would be dependent and which would be independent. Remember that dependent, as it sounds, talks about a value that depends on something else. So pause it now, have a go at some of these. Okay, so if we look at the first example, age and salary, a good way to think about this is read it out to yourself in terms of dependence. So age is dependent on salary, or salary is dependent on age. And think about which one makes more sense. Does it make more sense to say that your age changes with your salary, or that your salary changes with your age? So salary definitely changes with age, so salary is therefore dependent, and age, therefore, is independent. Homework hours and test results. Well, do our test results depend on how many hours of homework we do? Or does how many hours of homework we do depend on what our test results were? Hopefully, for most of you students, it's this way around. That your test result depends on your homework. Hair color and ethnicity, blood alcohol and reaction time, distance from home, comfort level and temperature, so on and so forth. So hopefully you got all these correct. And just remember, think about reading it out in terms of one is dependent on the other, or this is dependent on this, and see which makes more sense to you. Here's an example. Each week a department store employee receives a basic salary of $300. In addition to this, she is paid a bonus of $20 for each new member she signs up on the store's rewards club. If we let I be the employee's income, I for income makes sense, and M be the number of members that she signed up to the rewards club, M for members, what would the independent and dependent variables be? So just like in the previous example, think about, does her income, I, depend on the number of members she signs up? Or does the number of members she signs up depend on her income? So from the description, hopefully we can tell that the money she makes, which is her income, depends on how many members she signs up. Therefore, her income is the dependent variable. Part B says to construct a table and draw a graph of the income against the members, where they want us to set number of members signed up from 0, she doesn't sign any up, all the way up to she signs up 10. So the question tells us that if she signed up no one, she would still make her basic salary of $300. So mathematically, we could write M is equal to 0, which would imply that her income I is equal to $300. If she signed up one new member though, M is now equal to 1, and her salary would be the $300 plus $20 for the one member. So if I constructed a table of this, it would look like this, where I've got M, number of members signed up, and I, her income. Just as we said, if she signs up no one, she gets $300. If she signs up one person, she gets another $20. If she signs up a second person, she gets another $20 on that, and so on and so forth. Part C now wants to say, is the relationship linear? A good way to think about this is, we don't have a graph, so I can't just look at it and say, is it a straight line without plotting it, and I haven't been asked to plot it yet, so there's an easier way. In this example, we look at, what does M increase by? It increases by the same amount every time, right? It goes up by 1. So if M goes up by 1 every time, and I goes up by 20 every time, that means they're both increasing by the same amount every step. That tells us, that's another way of knowing that it's linear. If it increases the same every step, it's going to create a straight line. So yes, it is linear. Part D, is it sensible to join the points? Like we discussed in an earlier question, sometimes it doesn't make sense to connect the points together. So if we have all these points where M is the number of members, can we join a line? Is there such a thing as a 1.5 M value? Can we employ or sign up 1.5 members? Probably not. So in this case, no, we can't join the points with a line. We can only have the points. And for each new member signed up, how much does her income increase by? Well, that's just talking about the step increase, right? Her income. And we can see from the table it goes up by $20 for every new member. Here are some questions for you now. So question 2 and question 4, I've created space in the next few pages for you to do them. So question 2 should have enough space here, and this this axis graph here should be sufficient for you to put your answers in. So go to the document, load this up, and have a crack at question 2. Question 4, the same thing applies. I've created a blank space here for you to write the answers to it, and I've given you a huge table or axis on this side for you to plot the temperature versus Fahrenheit. So have a go at those.